Welcome to this explainer. Today, we're breaking down the absolute core philosophy of artificial intelligence. We're going right under the hood to see how a machine actually learns. We hear buzzwords like neural networks and large language models literally all the time. But before we rush into all those hyper-complex systems, we really need to understand the structural foundation that every single one of them is built on. So, how does a machine actually learn? It's a fascinating question, right? Look, a lot of people get incredibly frustrated by the math and just throw in the towel before they even start. But we are absolutely not going to do that today. We're going to follow the journey of a machine, starting from total absolute ignorance, all the way to complete mastery. And we're doing it step by step, completely avoiding the painful textbook math while still capturing the deep intuition behind the whole thing. Okay, here's our agenda for today. 1. The machine learning blueprint. 2. The real estate algorithm. 3. Math without the pain. 4. The core learning loop. And 5. Scaling to the real world. Let's jump in. Section 1. The machine learning blueprint. Prerequisites for AI. Before you even think about writing your first line of code, you need a few basic mental tools in your toolkit. You really don't need a PhD in rocket science here, but you do need to understand the fundamentals so you know exactly which buttons to push. If you know basic Python and just survived high school math, you are already equipped for this journey. Modern libraries really do the heavy lifting for us. On the Python side, just get comfortable with lists, loops, and basic functions. And for the math, the big three, we're talking about linear algebra, where data is just a grid of numbers, calculus, which is just understanding rates of change, and statistics to see how spread out your data is. If you've got those down, you're golden. Section 2, the real estate algorithm, finding the pattern. Let's ground all this theory with a super simple scenario. Imagine you're a real estate agent, and your goal is to predict house prices based solely on their square footage. You go out, collect data from 5 recently sold houses, and create a simple table of sizes and prices. Now, what's truly amazing here is that your human brain instantly spots the pattern without you even trying. Just look at how the price changes as the size increases. You instantly figured out the rule, didn't you? Each square foot costs exactly $200. So if someone walks up and asks you the price of an 1,800 square foot house, you just multiply it by 200 and boom, $360,000. Congratulations. You literally just acted exactly like a machine learning model. You took historical data, found the hidden rule, and used it to predict a brand new answer. Section 3, math without the pain, variables and equations. Here's the catch though. Real-world data is never that perfectly clean. It's messy. It's scattered all over the place. So our goal in machine learning is to find a straight line that perfectly fits through those scattered points as closely as possible. To do this, we use the exact same algebra equation from high school. You probably remember y equals mx+b. Well, in machine learning, we just swap the letters to sound a bit more sophisticated. We change m to w for weight, and we keep b for bias. In our real estate example, x is the input, the size of the house. Y is the target price we want to predict. That weight, W, is the multiplier, our $200 figure. And the bias, B, is our starting point. Think of it like, what's the base price of the bare land if the house size is 0? But we have to remember, when the machine boots up and starts its job, it knows absolutely nothing. 0. It doesn't know the weight, and it doesn't know the bias. It literally starts in a state of complete ignorance and just throws down a totally random, horribly wrong line across the graph. It might guess the multiplier is 5 and the base price is $10,000. It's just completely off. Section 4, the core learning loop. Predict, error, adjust. The absolute crucial point here is understanding how the machine goes from that terrible, random initial guess to a perfectly accurate prediction. I promise you, it doesn't happen by magic. It happens through a highly structured, repetitive 3-step loop. Step 1, make a prediction, which we call y-hat. Step 2, calculate the error using a cost function. And step 3, adjust those dials using a process called gradient descent. Let's look a bit closer at step 2. To actually get better, the machine has to calculate exactly how wrong its prediction is. It uses a cost function known as mean squared error. Simply put, it takes the actual price of the house and subtracts the predicted price. It does this for every single house in the data, squares those differences so the negative and positive errors don't accidentally cancel each other out, and then takes the average. And hey, if you were writing this in Python using a library like NumPy, it's basically a one-liner. You just calculate the mean of the actual minus predicted values squared. It's that simple in code. I actually really love the classroom analogy for this. Think of the cost function as a remarkably strict school teacher. The higher the error score this teacher hands back, the worse the student, our model, performed. The machine's sole purpose in its artificial life is to get this error score down to absolute zero.
So now the machine has its scorecard. It knows its error is massive, and it has to fix it. It does this in step 3 using an optimization algorithm called gradient descent. This is where the calculus comes in. Specifically, the algorithm calculates the partial derivatives with respect to the weights and biases. By mathematically deriving these partial derivatives, the machine pinpoints the exact slope of the cost function. This allows it to tweak those W and B dials in the steepest downward direction.
Now, if terms like partial derivatives sound intimidating, don't worry. Just imagine this. You are blindfolded on a foggy mountain. Being high up on that mountain represents your high error. You want to walk down to the lowest valley, which represents zero error. Because you're blindfolded, you can only feel the slope of the ground with your feet. If the ground slopes downward to your left, you take a tiny step to the left. Gradient descent works exactly like this, feeling the slope, taking tiny steps downward, until you finally hit the bottom of the valley. But taking one single step isn't going to get you off the mountain. The machine repeats this entire loop thousands, sometimes millions of times. Predict, check the error, feel the slope, adjust the dials, over and over and over. Slowly, the error shrinks closer and closer to zero until it hits the absolute bottom of that valley. It officially masters the data. And guys, that is exactly what we mean when we say a machine learns. Section 5, Scaling to the Real World, Industry Applications. Looking at our simple little 2D housing example, you might be wondering, are trillion-dollar tech giants really just drawing straight lines through data? The answer is a massive, resounding yes. The real-world scale is unimaginably larger, but the fundamental logic is identical. The exact same underlying math we just walked through scales up to handle thousands of variables simultaneously. Wall Street uses advanced regression to predict market trends. Walmart uses it to predict inventory needs based on weather and holidays. Google and Meta, they use it to predict the precise probability of you clicking on an ad. It is literally the same 3-step loop, just running at a massive scale. To wrap up this explainer, I want you to remember these core takeaways. First, seriously, don't let the math intimidate you. Data is just a grid of numbers, and learning is fundamentally about adjusting weights and biases in y=wx+b. Second, memorize that core loop. Predict, calculate the error using your strict teacher cost function, and adjust the dials using gradient descent. And finally, appreciate the scalability. The surprisingly simple mathematical loop powers the entire global tech economy. So, I'll leave you with this thought. Now that you completely understand the foundational blueprint and the true inner workings of machine learning, are you ready to fire up a library like scikit-learn and actually write the script to bring this to life? The machine starts its journey in absolute ignorance, but do you have to stay there? Keep pushing, keep learning, and I'll catch you in the next explainer.